Hello, Mathies Gatos here. Welcome to Chapter 2, Trigonometry. In this video, we're going to cover Section 2.1, which is angles in standard position. So let's begin by talking about what an angle actually is. An angle is formed by two rays with a common endpoint, and that endpoint is called a vertex. Now, the vertex connects these two rays. One of the rays is the initial or starting position. That's the fixed position. And the terminal arm is the ending position. So the terminal arm is the one that moves back and forth. And the distance between those two would be the angle, which is measured in degrees. Now we're going to be talking about angles in standard position. So an angle in standard position has the vertex at the origin, the initial arm always on the positive x-axis, and it is the terminal arm that rotates counterclockwise throughout the coordinate grid. So here's some examples of angles that are in standard position. So those again are formed by having a vertex right at the origin, an initial arm right at the x-axis, and the terminal arm which moves around. These angles are not in standard position. Here, because the vertex isn't at the origin. Here, because the initial arm isn't at the x-axis. And here for both reasons. Vertex is not at the origin, and the initial arm is not at the x-axis. Now, when we measure angles, we're talking about measuring them in the Cartesian plane or the coordinate grid. Now, coordinate grid is going all the way around, which is 360. Because there are 4 quadrants, 360 divided by 4 means that 90 degrees is in each of the quadrants. So this is where I start, and this is where I also end. So I start at 0 degrees, I go 90 degrees, 180, 270, and then back to end at 360. So each of those quadrants is split into 90 degrees, and you need to know how each quadrant is split up. So quadrant 1 is between 0 and 90, quadrant 2 is 90 to 180, quadrant 3 is 180 to 270, and quadrant 4 is 270 to 360. We're also going to talk about reference angles. Now, reference angles denoted as theta sub r. Reference angles are a positive acute angle. Acute meaning it's between 0 and 90 degrees. Now, an acute angle, reference angle, is the angle made between the terminal arm and the positive or negative x-axis. So I just want to show you an applet as to what a reference angle is. So here we can see the coordinate grid here, and we're going to draw triangles going around this coordinate grid. Now the angle in blue is your standard angle, the angle in red is your reference angle. So what you'll notice is in quadrant number 1, no matter where I have my angle, you can see that the angle and the reference angle are the same because they're both acute angles. Now let's move over into quadrant number 2. So moving over into quadrant 2, for example, this angle here, 115 degrees. So it's in quadrant 2 because it's greater than 90 but less than 180. Notice the red reference angle here is the angle that I make with the terminal arm and the negative x-axis here. So all in here, they are not the same angle measurement, but what you can see is that the angle measurement, 146, and the reference angle, 34, those add up to 180 degrees, which is along the negative x-axis. So to figure out what the reference angle is in this quadrant, I just take 180 degrees, subtract my angle to get my reference angle, and that will happen for any angle in quadrant number 2. Now let's jump into quadrant number 3. So jumping into quadrant 3, you can see my angle here. It's greater than 180, but less than 270. So in between 180 and 270. And you'll notice that the reference angle, still an acute angle. This is the angle that I am past 180. So see here I'm at 216 degrees. I'm 36 degrees past 180. Or if I go down to here, 231 degrees, I am 51 degrees past 180. So in this quadrant here, the reference angle can be found by taking the angle subtract 180, and that will work anywhere along here. In quadrant number 4, when I jump into quadrant number 4, my angle measurement is going to be between 270 and 360. Now you'll see the red reference angle is still an acute angle, which is less than 90 degrees, but let's look at how we figure that out. So let's say, for example, I have a nice angle like 310 degrees. So 310 degrees, you can see there are 50 more degrees to get to the x-axis. Or if I go 320 degrees, there are 38 degrees more to get to the x-axis. To figure out what the reference angle is here, I take 360 degrees and subtract it from my angle. So let's go back to our notes now that we've seen that and come up with that. So in quadrant number 1, 2, 3, and 4, how can I figure out the reference angle? So first thing we're going to do, since the reference angle is the angle, the acute angle that it makes with the terminal arm and the x-axis, the first thing I'm going to do is look at my x-axis angles, which are 360 degrees and 180. What we're going to do is compare the angle to the angle at the x-axis, 180 or 360. Choose the bigger one. Which is bigger, the angle or the x-axis angle? And then all you have to do to figure out the reference angle is do big angle minus the small angle. So let's look what that would look like in quadrant number 1. So in quadrant number 1, all the angles there are their own reference angle. So the reference angle is the same as the angle. In quadrant number 2, 180 degrees is the bigger one. So I'm going to figure out my reference angle by doing 180 minus the angle, big minus small. In quadrant number 3, the angle in quadrant number 3 is bigger than 180. So in this case here, to figure out my reference angle, I'm going to take my angle minus 180. Again, big minus small. In quadrant number 4, 360 will be the bigger measurement. So 360 degrees is bigger than the angle in quadrant 4. So the reference angle can be found by doing 360 take away our angle. So this is something that I want you guys to commit to memory because we need to know how to find a reference angle in each of the quadrants. Let's try an example here. So in this example here, I want to sketch the angle in standard position and label the reference angle. So 120 degrees, I know that is a quadrant 2 angle. So if I come right to here, there is 120 degrees. So if I want to sketch that angle, I can look like this, pull it over. There is 120 degrees. So remember I said you always compare it to the x-axis angle. So at the x-axis here, the negative x-axis, I have an angle that measures 180 degrees. Now 180 degrees is bigger than my angle. So to figure out my reference angle will be 180 take away 120, which means that my reference angle is actually going to be 60 degrees, which is right in here. Let's try 310 degrees. So 310 degrees is a quadrant 4 angle. So I'm going to go all the way to quadrant number 4. There's 310 degrees. And I'm going to sketch that angle. So there's what 310 degrees looks like. Now I always compare it to my x-axis angles, which is 360. And 360 is the big angle. So my reference angle, always big minus the small. So in this case here, my reference angle is 50 degrees, right in there. So reference angle, always an acute angle made with the terminal arm and the x-axis. If I look at 240 degrees, that's a quadrant 3 angle. So quadrant 3, around here, there's 240 degrees. So I'll sketch that angle. And then compare that to my x-axis angle. And my angle itself is bigger. So reference angle is always big minus small. So the big angle minus the small angle. And that's a reference angle of 60 degrees. So I know in here, the angle, the acute angle with the terminal arm and the x-axis is 60 degrees. Okay, what if I asked you to sketch all the angles that had a particular reference angle, such as 80 degrees? So if I wanted to sketch those angles, so again, remember in quadrant number one, the angle is its own reference angle. So 80 degrees is the reference angle and also the angle in quadrant one. In quadrant number two, 180 is the bigger angle, so I do 180 minus my reference angle to get an angle of 100 degrees. In quadrant number three, the angle itself would be bigger than 180, so I just do 180 plus the reference angle because it's more than 180, and I would get that my angle with a reference angle of 80 would be 260 in quadrant three. And in quadrant number four, I'm just going to do 360, take away my reference angle. So for all of these examples, always big minus small. So that can be used to find the reference angle and to also find the angle itself. So this angle here would be 280 degrees. Let's talk about using special reference angles of 30, 45, and 60. This will all come together, you'll see, in our next lesson. So if I had a reference angle of 30 degrees, I want to label this triangle using a 30-degree angle. So what I'm going to do is I'm going to go to my calculator and I'm going to enter in sine, cosine, tangent of 30. And I see that sine of 30 is a nice value. It's just 0.5. Now sine of 30, 0.5 is the same as 1 over 2. Using what I know about SOHCAHTOA, sine meaning opposite over hypotenuse. Well, since I know that sine of 30 is opposite over hypotenuse, which is also a half, I can label my triangle. Here's 30 degrees, and I can label it as opposite over hypotenuse, 1 over 2. Now, let's use Pythagorean theorem to find our missing side. So Pythagorean theorem would say c squared minus b squared equals a squared, or 2 squared minus 1 squared equals 3. So this side here would be the square root of 3. Now that I've labeled that triangle, I can now know the exact values of sine, cosine, and tangent of 30 degrees, and it would look like that. So sine of 30 is a half, cos of 30 root 3 over 2, and tan of 30 is 1 over root 3, or if I rationalize my denominator, root 3 over 3. Let's look at that previous triangle and notice that there is one angle that's missing. So if I use what I know about angle sum, all the angles in a triangle add up to 180. So 180, take away the 30, take away the 90, makes this angle 60 degrees. So without doing that whole process again, I now know based on 60 degrees, 3 more ratios. So I know that sine of 60 is root 3 over 2, cos of 60 is a half, and tan of 60 is root 3 over 1, which is just root 3. So in the 30, 60, 90 triangle, I know 6 different ratios. And let's summarize those. So 30, 60, 90 triangle, I know all 6 of these ratios. Now, how are we going to remember that? Well, the tip that I would use for this is either remembering what we started with, sine of 30 is a half, or just remembering that root 3 is beside 30 degrees. So this might be an easier one to remember here, is that root 30 is right by 3, and then the other two sides are a half because sine of 30 is 1 over 2. So now using that special triangle, I know 6 ratios, but there was one other angle I wanted to look at, which is 45. So looking at this one here, if I have a 45, 45, 90 triangle, I'm going to do the same thing. So I'm going to look at sine, cosine, and tangent of 45 degrees. And I can see the one that's nice there is tan of 45. So using SOHCAHTOA, t standing for tangent is opposite over adjacent, which I know is 1. So since tan of 45 is 1, opposite over adjacent is 1. And then again, I can use Pythagorean theorem, putting this together to figure out that my hypotenuse, a squared plus b squared equals c squared, would be root 2. So 2, and then of course we square root it. So now that I know that, my 45, 45, 90 triangle looks like that. Here are all my exact values for sine, cosine, and tangent of 45 degrees. And putting that together, my 45, 45, 90 triangle. My tip for you to remember that is that tan of 45 is 1. And because it's 1, it's also an isosceles triangle because opposite and adjacent are the same, making it an isosceles triangle. Now, another way that you can remember this is a hand trick. And this is something we use in 30-1, so might be useful to remember this now. So to figure out what the hand trick is, you can hold your left hand up so that your pinky is along the positive x-axis, 0 degrees, and your thumb is along the positive y-axis at 90 degrees. And then in between here, you have 3 fingers, 30, 45, and 60, going in numeric order. Well, the shortcut to figuring out or remembering sine, cosine, and tangent is by using the fingers above and below. So in alphabetical order, cosine is going to be the number of fingers above, sine will be the number of fingers below. So cosine is going to be root of the fingers above over 2, sine will be root of the fingers below over 2, and tangent will be root of below over above. So what we can do is just fold down each of those fingers and figure out all the trig ratios that the special triangle also helped us with. So for example, if I fold down my 30-degree finger, so if I fold down my 30-degree finger, I can look at that and say that cosine of 30 degrees is, how many fingers above? 1, 2, 3. It would be root 3 over 2. And then sine of 30 degrees would be the fingers below, which you can see is 1. And root of 1 is 1 over 2. And you can repeat that process for 45 and 60. You can do the same thing for tangent as well. I do have a video on my YouTube channel in the 30-1 playlist showing you how to use the hand trick fully if you'd like to use that as well. So let's put this together in just one question here where you can see where all the triangles and the exact values are kind of coming together. So in this question here, I want to find the exact area of a triangle as shown below. So this triangle has a height of 16, base angles of 45 and 30, and I want to find the area. So what I'm going to do is use the height of 16 to split it into 2 triangles. So in my first triangle here, looking at this one here, this is my 45, 45, 90 triangle. I want to solve for base 1. So looking at my angle here, I have an angle, I have an opposite side, and an adjacent, which is tangent. So let's write that out. Tangent of 45 degrees is equal to opposite, which is 16, over adjacent, which is base 1. Now, tan of 45, I know from either my special triangle or my hand trick is 1. So 1 equals 16 over base 1. So what that means is that I know base 1 has to equal 16 because 16 divided by 16 is 1. Now, let's go to our other triangle, the 30, 60, 90 triangle, and I want to solve for base 2. So in this case here, I have an angle, I have an opposite, and again an adjacent, which is tangent. So let's write that out. So tangent of 30 degrees is equal to opposite 16 over adjacent, which is base 2. Now, tangent of 30 degrees, I can go to my 30, 60, 90 triangle, or use my hand trick, like this. So remember that I said sine of 30 is 1 over 2, and the root 3 goes along the 30-degree side. So tangent of 30, opposite over adjacent, would be 1 over root 3, which is the same as 16 over base 2. So to solve for base 2, I'm just going to cross multiply and divide, and I get that base 2 is 16 root 3. So I know that my base altogether is base 1 plus base 2. So the base is going to be 16 plus 16 root 3. And now we can figure out what the area of this triangle is, the exact area. So area is equal to base multiplied by height divided by 2. So looking at this, I'm going to have, well, I can just simplify this. 18 divided by 2 is 8. So I'm going to have, factoring out a 16 here, I will have 16, 1 plus root 3 multiplied by 8. And then I can just multiply those two values together. So multiplying those two values together, I'm just going to have 16 multiplied by 8, which is 128 times 1 plus root 3. And then I don't know what my units are, so I'll just call them units squared. So altogether, my area is 128 times 1 plus root 3 square units. And that would be my exact area of the triangle. So remember, when you guys are doing this, SOHCAHTOA is going to help you solve for the missing sides and also find the missing trig ratio. So I hope this video helped. You guys can go on and do practice 1 to 4 and then move on to your textbook questions. And I'll see you for the next one.